Welcome back. Let's continue with our lesson. We have properties of congruent shapes that we have dealt with. Now we are moving to properties of similar shapes. Similar triangles have proportional corresponding sides. And let's look at the two triangles, triangle ABC and triangle JKL. When we say proportional, we are looking at it from the smallest side, shortest side in the triangle is side AB. Let's write it out. And the shortest side in the next triangle is side JK. So when we say proportional, we are saying if you divided the two sides, you would get a ratio that we're going to relate to as we continue. And that should mean then be equal to the ratio we will get when we divide the longest side, which is the hypotenuse, that is side AC, and divide it by side JL. And that also should be the same ratio we're going to get when we divide side BC, which is adjacent to the right angle, and divide it with side KL. So when we say proportional, it will come out of the ratio that we're going to get, and then corresponding means that we're looking at a side that is proportional, corresponding to, in terms of the shape. If it's the shortest side, we're looking at similar sides on both sides and on both shapes. And if we are looking at the hypotenuse, the longest side, we're going to look at the hypotenuse on both of them. All right. Let's look at the conditions of similarity. The first one is the corresponding angles are equal. And let's look at triangle ABC and triangle XYZ. As stated there, it says angle A equals to angle X. And we have a double marking there and a double marking on angle X. So those are the two angles that are equal. And angle B would then be equal to angle Y. And we have a triple marking there and a triple marking in angle Y. And then angle C equals to angle Z. We have a single marking on angle C and a single marking on angle Z. So when we talk of corresponding angles, that's what we are talking about. And the second condition of similarity is that the sides are proportional. And when we look at it, we look at it now from triangle ABC and triangle XYZ. Look at the sizes that have been given. We are given side AC to have 2 units, while side XZ equals to 1 unit. And side AB is 6 units, and side XY is 3 units. And if you look at AB and you'd write 6 divided by 3, let's write it, 6 divided by 3 would be equal to BC, which is 4, divided by 2, and equal to AC, which is 2 divided by 1. So 6 divided by 3 gives us 2. 4 divided by 2 gives us 2. And 2 divided by 1 gives us 2. And that ratio then shows that these sides are proportional. Let's look at the next part. Similar quadrilaterals have equal corresponding angles, and the corresponding sides are proportional. So it doesn't only speak to triangles, even quadrilaterals have similarity. Let's look at WXYZ and ABCD. Those are 2 trapeziums. And when you look at that, you would see that, let's look at the first part, which is the corresponding angles. So which means that angle W would correspond with angle A, and angle X would correspond with angle B, and angle C corresponds with angle Y, as well as angle D, which we're going to use 4 markings, will then correspond and be equal to angle Z, which has 4 markings. So that is when corresponding angles are said to be equal. Now let's look at proportional sides, because that the sides have to be proportional. That means side WX will then be proportional to side AB, and which must be equal to side XY, which must be proportional to side BC, and side YZ is proportional to side DC. Remember, we're looking for a ratio that would be equal, and then the last one would be side WZ is proportional to side DA. All right, so that's proportionality. And also remember that congruent quadrilaterals are also similar. All right, let's move on to the next one, which is other shapes that may not necessarily be a triangle or a quadrilateral. And I'm looking at pentagons here. And it says that JKLMN and ABCDL are regular pentagons. So I'm looking at a pentagon is a shape that has 5 sides, and the word regular means that all the sides of that pentagon are equal and all the angles of that pentagon are equal. Therefore, that means angle K equals to angle J, and angle N and angle M and angle L. So all those 5 angles are equal, and the sides, side KJ equals to side JM, N, and side MN, and side LM, and side KL. So all those 5 sides are equal. And then the next pentagon, and similar, because of the word regular, that means angle A equals to angle B, which equals to angle C, which equals to angle D. And you notice that we've already marked L, and now same L equals to equals on both pentagons. And then the sides, we have side AB equal to side BC, equal to side CD, equals to side LD, and equals to side AL. So that's what regular pentagons mean now. And the question was, are the 2 pentagons similar or not? And our part would be, yes, they are similar. And what would be our reason? Because they said why, then we would say all corresponding angles are equal. Another condition of similarity is if 2 triangles have the, if 2 triangles are similar, then the sides are proportional. Proportional means that the ratio of the sides is the same. Let me make you an example. I've got triangle ABC and triangle XYZ. Looking at the 2 triangles, you would see that AC has 2 units. We don't say centimeters unless they give us centimeters or meters. But if they write a number, then we take it as 2 units. So AC has 2 units and XZ has 1 unit. Right? AB has 6 units and XY has 3 units. It's almost like half. So let's look at how we would represent that in terms of writing it. We then say, if side AB is divided by side XY, there's side AB, it gives us 6, and it's divided by side XY, which gives us 3. And then we look at the next one. Maybe let's write it further here. 6 divided by 3 is equals to, let's look at the next one, side BC, which gives us 4, and is divided by side YZ, which gives us 2, it would be equal to 4 divided by 2 and equal to AC, which is 2, divided by XZ, which is 1. When we divide this, 3 divided by 2 would give us 2, 4 divided by 2 would give us 2, and 2 divided by 1 will also give us 2. Therefore, we say they are proportional. In other words, the ratio of all the sides is the same. The outcome, this is the proportion that we're looking at. The outcome of those sides divided gives us the same answer. Therefore, they are proportional. So those are the two conditions. It's either the angles are equal or the sides are proportional. Let's look at a quadrilateral in terms of similarity as well. Similar quadrilaterals have equal angles but different sizes. Remember, congruent quadrilaterals are also similar. As we were saying with the triangles, as long as they are congruent, they are the same. So similarity is there. However, with similarity, we look at the size. And with congruency, the size must be equal. So look at the two trapeziums. I've got WXYZ, which is the first trapezium, and trapezium ABCD. Shaped the same, they look the same, they probably have the same angles as given there. However, the one is smaller than the other, and therefore, because of that, we then say, when we can identify that the angles are all equal, therefore those two trapeziums would be similar. Let's look at another question. JKLMN and ABCDL are regular pentagons. Remember, pentagon, we said, is a figure, it's a shape that has 5 sides. Regular means that all the angles are equal. Therefore, that says to us, let's read the question, are the two pentagons similar or not? By virtue of them being regular, it means that angle J equals to angle B, and angle N equals to angle C, and angle M equals to angle D, and angle A equals to angle K. And of course, angle L is common. So all the angles are equal. By those angles, we are then saying JKLMN is similar to ABCDL because all angles are equal. Now I'm writing angels. All angles are equal. However, if we were not using the angles for that question, we'd then look at it from proportional sides. Look at side KJ. Let's make that to be equal to X. And look at side AB and make that to be equal to Y. And let's make the sides that we're using. So KJ divided by AB. Remember, we're dividing with the corresponding side. If we were to divide that, the answer would be X divided by Y. If we divided JN, because it's a regular pentagon, it means the sides are also equal to X. So it would be, the next one would be JN divided by BC, and it would give us X divided by Y. So all the sides would give us X divided by Y. And because the ratios are the same, therefore these sides would be proportional. And because of them, it then means that these two are similar. Okay, let's look at a typical question. The two triangles are marked. Show that triangle JLK is similar, that is the symbol for similar, is similar to triangle PQR. Let's look at the two triangles, and what do you see in our markings? You see that the sides have been marked. So let's look at those sides, and what do you notice? This one is 10, that side is 5. So when you look at the other one, this side is 4, that one is 8. So let's look at a ratio we could use there. It would be LJ divided by RP or PR. Let's use PR. LJ divided by PR would be equals to 10 divided by 5, which gives us 2. Let's look at the next one. KL divided by RQ, it would be 8 divided by 4, which gives us 2. And JK divided by PQ, which gives us 4 divided by 2, which is 2. If all the numbers are the same, then the two triangles are similar, and that therefore we can say that the corresponding sides are proportional. Corresponding sides are proportional. And remember, if the ratios are not the same, that means those two sides or those two shapes would not be similar. All right, let's look at another typical question. Two triangles have been marked. Prove that triangle ABC is similar to triangle DEF. Let's look at what we have. We can see that there is angle B, which is 35, and angle E, which is 35. So we'll write that angle B equals to angle E, which equals to 35 degrees. And then the next one is angle 65 and 65, which is angle A, which equals to angle D, which equals to 65 degrees. And we notice then again that there is angle 80 degrees and angle 80 degrees. So we say angle C equals to angle F, which equals to 80 degrees. And then we say because the angles are equal, therefore triangle ABC is similar to triangle DEF. And what would be our reason? Would say all angles are equal. All angles are equal. Okay, let's move on to the next one. Use the markings on the triangles to prove that triangle ABC is similar to triangle JKL. Now let's look at the markings they have given us. They have a 60-degree angle and a 60-degree angle. Then there is a 30 and a 30-degree angle. And of course, there is a 90-degree angle. So because of that, we are able to say angle A equals to angle J, which equals to 60 degrees. And then angle C, equals to angle L, which equals to 30 degrees. And angle B equals to angle K, which equals to 90 degrees. And therefore, triangle ABC is similar to triangle JKL because all the angles are equal. All angles are equal. So similarity deals with the same angles and different sizes, whilst congruency deals with the same angles and same size. So it's about that. Let's stop that for today. Hope you enjoyed today's lesson. See you soon. Goodbye.